All right, pre-algebra, here are your exponent review questions, and we're going to go ahead and go through the answers. So our learning target is that I can use the properties of exponents to write equivalent expressions. We're going to fill in the following table using the chart in our notes to help in this OneNote page if we're stuck. Okay? So the first thing we're going to do is, what is the rule if we fill in the blank? So for our product rule, when multiplying two numbers with the same base, we are going to add the exponents. So what that would look like is if we had algebraic a squared times a to the third, and this is just an example. Okay, so we're creating our own example, equals a to the fifth, because we just add our exponents. If we wanted a numeric one, we want it with no letters, so if we just changed our first example to be 2 squared times 2 to the third is also 2 fifths. So this being our answer. When we're talking about the product rule for different bases, when multiplying two numbers with different bases, we multiply the bases and we keep the exponents the same. So what would this look like algebraically is if we had a squared times y squared equals a times y squared. Or if we were using numbers, 3 squared times 4 squared equals 12 squared. So your examples can look different. As long as they're about the same kind of examples, we should be on the right track. Now, when we're doing the power rule, when raising a power to another power, we are also going to multiply the exponents. We are giving those exponents extra power. So that might look like a squared to the power of 3 is a to the 6th. If we were using numbers and only numbers, we could change that letter a to be 3 squared to the power of 3, which is 3 to the power of 6. So keeping that base, but just multiplying our exponents. And then last but not least, when dividing two numbers with the same base, we subtract the exponents. So that would look like a squared, or a to the third, sorry, over a squared would be a to the 1. So we subtract the exponents. 3 minus 2 is 1. And then if we're just using numbers, we might put a to the 7th over a to the 3rd, which would be, oops, I'm sorry, I'm supposed to be using numbers. So maybe we're putting 2 to the 7th and 2 to the 3rd would be 2 to the 4th, because 7 minus 3 is 4. So using those examples to help us with the problems down below, these are all of the product rules that we learned in 1-5. So let's put this into practice. All right, so we have the same base, but different exponents. So we're going to take our exponents and we're going to add them. So 2 plus 4 equals 6. So we're going to have x to the 6th. This being our final answer. Now we have our quotient rule. So remember, we subtract the exponents. So this equals y, numerator minus the denominator, equals y squared. Okay, and when in doubt, you can expand this out to c. But we're using our 4 rules from up above. Okay? When we have c, we have power of a power. So we're going to take our exponents and we're going to multiply them. So we have 3 times 6, which is equal to, keep the base, multiply the exponents, so b to the 18th. because 3 times 6 is 18. And then last but not least, we have our two different bases with the same exponent. So we multiply our bases and keep the exponents. So we have 3 times 2, which is 6, and we keep the exponent. So 6 to the 4th is our final answer. Jumping down, we have 5 to the 4th and 10 to the 4th, so the same problem. Different bases, same exponent. So we're going to multiply our bases and get 50 and keep the exponent. We have power of a power, so we have 2 and 8, so we're going to multiply those together. So that equals k, keep the base, to the 16th, because 2 times 8 is 16. Letter G, we have same base but different exponents, so we're going to take our exponents and we're going to add them. So we get t to the 9th. And when in doubt, you would expand that out. Notice that you have 9 t's all being multiplied together. In letter H, we have the quotient, so we're going to take our exponents and we're going to subtract them. So y, numerator, minus the denominator equals y to the power of 2, being our final answer. Jumping over to I, again, we have the same base but different exponents. So we're going to take our exponents, and because it's division, we're going to subtract those exponents. So we have d, numerator minus the denominator, which is d to the 20th. Our next one, we have different bases, but the same exponent. So we're going to take our two bases and multiply. 4 times 3 is 12, and we keep the exponents. 12 to the 3rd. Letter K, we have power of a power, so we have our two exponents, and we're going to multiply them together. We have r, 8 times 3 is 24. This being our final answer. Letter L, we have the same basis. So notice that we have 3, but we're not going to let that throw us off. So we have x to the 3rd, x to the 6th, and x to the 4th. So we're going to go ahead, same base, different exponents. We're going to add all of these numbers together. So what we get is x. 3 plus 6 is 9, plus 4 is 13. So adding them, it doesn't matter if there's 3 of them, they all have the same base, so we can add those exponents together. All right, moving into a new section. So this really should say 1/6, but we're going to be able to write our numbers using negative and 0 exponents in different ways. So let's jump down to fill in our chart. Anything raised to the 0 power is 1. Easy. Okay, so if that looked like algebraically, we'd have a to the 0 equals 1. If we were using only numbers, 2 to the 0 is still 1. Any negative exponent is not allowed in our answers, so we cannot have negative exponents in our final answer. So if we had a to the negative 3, we'd want to change that, put it over 1, flip our fraction or use our elevator method, and we would have 1 over a to the positive 3. Now our exponent is happy. If we were using numbers, we'd have 2 to the negative 3. Again, we cannot have a negative exponent, so we have to flip our fraction to equal 1 over 2/3. Okay, and don't forget you can go the opposite way. So maybe in my number 1, I would have put 1 over 2 to the negative 3. And we could have flipped that to the numerator so that it's only 2 to the 3. So you can do it either way. Have it in the top and take it to the bottom, or have it in the bottom and take it to the top. Either way, you cannot have negative exponents in your final answer. So let's jump down. Let's put this into action. On letter A, we want to make sure that we have positive exponents only. So on letter A, 4 to the power of 0, anything to the power of 0 is 1. Noticing here, 5 to the negative 3rd, I am not allowed to have that. So what I'm going to do is put this over 1, and I'm going to flip my fraction, or I'm going to use my elevator. It's telling me I need to go down, so I'm going to go down to the bottom. So my final answer is 1 over 5 to the 3rd. Keeping that exponent positive because we flipped our fraction. We flipped it from a sad exponent to a happy exponent. Letter C, this one I know that we were overthinking a lot. Because we have that multiplication symbol inside, that 0 belongs to the C. So this is really saying 2 times 1, and 2 times 1 equals 2. And that's our final answer. So don't get thrown off. Separate those. Letter D, I notice that I have a negative exponent, so we're not allowed to have that. It is sad. Okay, remember that negative sign just means wrong. I'm in the wrong spot. So we need to move that negative exponent to the numerator by just flipping our fraction. So what we really have is p to the 20th over 1, which is really just p to the 20th. We don't need to see that it's over 1. It is just p to the 20, because anything divided by 1 is itself. Jumping down to letter E, again, a negative exponent. So what we have to do is turn it into a fraction and flip that fraction. So our answer is just 1 over x squared. It was sad, now it's happy. Y to the 0 exponent, anything to the exponent of 0 is 1. G, I have a negative exponent, so that means I need to flip it. It's in the wrong spot. I'm going to flip my fraction. So this is v squared over 1, which is just v squared. V squared should be our final answer. This is not fully simplified, so fully simplify your answers all the way, just like your derivative wouldn't have accepted that as a final answer. And then last but not least, again, another exponent of 0, but all of this 1/2 is being taken to the power of 0, and anything to the power of 0 is 1. So don't overthink that. Don't be scared by that fraction. Okay. Remember, you guys, the numbers that you're seeing here on your review are going to be very similar to the questions that you see on your quiz. That is the end of your review. If you had to make any changes to your review, please resubmit and make sure it has all of the correct answers and it has all of its work shown. Otherwise, you will not get a retake. So make sure you fully complete your review and study hard.